Okay, just like we saw carbocation rearrangements by the movement of a hydride, a tertiary hydride to a secondary carbocation, we can also see carbocation rearrangements with 1,2 alkyl shifts. And again, it's the same type of a process where I'm forming a secondary carbocation and then I'm moving something over. In this case, it's going to be an alkyl group to form a tertiary carbocation. Okay. And so again, we're going to look at alcohols. Now, this can happen with any type of an SM1 or an E1 reaction. In other words, it doesn't matter what it is. Anytime I form a secondary carbocation, I can have a rearrangement reaction. So I went ahead and I protonated. Okay, I formed my good leaving group. And what I'm going to do is I'm now going to have, the secondary carbocation form. And we know when I'm reacting alcohols with HCl, I'm going to get SN1. Secondary alcohol with HCl, I'm going to get SN1. And so I form chloride in the first step. So Cl minus is going to come and it's going to attack the secondary carbocation. And then, of course, I'm going to get this mixture, this here. I didn't show any stereochemistry at the beginning, but it doesn't matter because you still need to know that you're going to form both the R and the S in enantiomer. Okay, so that's step one. So this is the formation of the product before rearrangement. And just like before, we're always going to see product made before and after the rearrangement. And so, sorry, I ran out of room there. So let's go ahead and let's look at what happens, okay, in terms of the shifting. So again, the same step is the same. I'm going to protonate my oxygen atom. I'm going to form a good leaving group. Water is going to leave, and now I'm going to have this secondary carbocation. And so I have a secondary carbocation, and next to it, I have a quaternary carbon. Okay. And so I have this CH3 group here. They're all identical. So again, it doesn't matter which one you use. Okay. I have this CH3 group here. And what I can do is I can have a 1,2 alkyl shift. Now, again, remembering the carbocation right now is residing on a carbon that is hypovalent and only has 6 electrons. Okay. And so when I move my alkyl group, my methyl group, I'm going to move it over as a so-called methide anion. Okay. In other words, I'm going to take I'm going to take the electrons with it. Okay. The electrons that are forming the bond between that terminal methyl group and that quaternary carbon are going to go with the CH3 group. And so what that's going to do then, so I'm going to have this shift that is then going to give me this here. Okay. The methyl group that I just moved is now over here because it left and it took its electrons with it. I'm now going to have a carbocation there. And the chloride, again, that I formed in the first step is just patiently waiting, will then come and do a substitution reaction. Now, we don't have to worry about stereochemistry here because why? That is not a chiral center. But again, so here we're going to have products that are forming before rearrangements. And here we're going to have products that are forming after rearrangement. And typically with alkyl shifts, we can shift methyls even up to ethyls, but don't worry, in my class, we're only going to see methyl shifts.